I'm going to show you today how you can write a Telegram bot that responds to a stream of events that comes from somewhere like Twitter, for example, builds that into materialized state store that we can query directly from our bot. So you've got events coming in our case Twitter, they stream into Kafka, ksqlDB materialize that stream into a state store, and Telegram, we're going to write a bot, a bit of Python code that's going to run lookups against that state store in response to queries that the users send to it. So there's various bits and pieces to the jigsaw, so let's see how we're going to put those together. To start off with, we're going to take data from Twitter and we're going to stream that into Kafka. We're going to do that using Kafka Connect, and for that we'll need the credentials from Twitter. So Twitter has got an API that we can sign up for access to using the developer portal. So go along to Twitter developer portal, sign up there for your credentials, and you'll get 4 secure pieces of information, some access tokens and secret keys and that sorts of stuff. Those are the 4 pieces of information you'll need to set up the connector for getting data from Twitter into Kafka. So I'm using ksqlDB here, and the first thing I'm going to do is create myself a source connector. So we use Kafka Connect under the covers. We're going to create a Twitter source connector. We're going to pass in our credentials from a file that's deployed on the Docker container as well. And we're just going to pull in tweets that have got any of these particular words in them. So we go and create that, and we say show connectors, make sure that it's running, and it says it's running. And if I say show topics, it says hopefully any moment now. We'll end up with a topic for our Twitter data. So our first tweets have been received. And we can print that topic there and see what all the data as it comes in. So depending on the filters that you set, you either get like a stream full of stuff at this point, or just like the odd tweet every few seconds as it trickles in. So we'll cancel that. But what we did there was simply take a Kafka topic and dump the contents to the screen, which is kind of useful. I'm going to tell ksqlDB that when I'm querying a topic, I want to start from the beginning of it, because Kafka stores the data, and we're going to say in this case, process all of the data that we've got. Taking the topic and dumping the contents to the screen is okay, but particularly with a complex payload like Twitter, it's kind of not so useful to see all of these different fields. So what we're going to do now is we're going to declare a schema for that topic, and this is called a ksqlDB stream. So we say create a stream tweets against this particular topic, and we say to ksqlDB the data is in Avro format. So when we set up Kafka Connect, we said serialize the data using Avro, so it produces the data onto the topic, stores it as Avro, which means the schema itself gets stored in the Confluent schema registry. So as users, we're very happy about this because we can go and use the data, and we simply say the data's in Avro format, go and create a stream, and ksqlDB or any other consuming application for that matter can go to the schema registry, pull down the schema, and now we've got access to the schema. Let's have a look at that schema. Describe tweets, tell me about the schema behind it. And it's a fairly complex schema. We've got arrays, we've got structs. If we page up, we can see things like the user, who's got a struct of an ID and their name and their screen name, which is the Twitter handle, and all sorts of stuff like that. Because we've got a schema associated with it, we can actually query the data and project certain fields that we're interested in. So we can do stuff like this. Tell me from the Twitter stream just the text of a tweet, just the user's handle, the screen name, and the time at which it was tweeted, the time it was created. Use a function here to cast that from a big int into something human readable. So we do that, and because we set the offset back to the earliest, this is going back to the beginning of the topic since we started populating it a few moments ago, and now it's caught up from the beginning of the topic through to the end, and now we just get a live stream of those messages as they're arriving in the topic, kind of like trickling on by every few moments. So we've picked out different fields from that stream of tweets. Now what we're going to do is we're going to say, well, of those tweets, we can see who's doing the tweeting. We've got the different usernames here. I would like to summarize that up. I would actually like to be able to know for each different person, how many times have they tweeted? When was the first one? When was the last one? What was the most recent thing that they said on Twitter? And we're going to materialize this into a state store within ksqlDB that using an external application, our Twitter bot in this case, we can actually query directly. So let's see how we're going to do that. We're going to create ourselves a table which is going to store this aggregate. So let's clear that. And here's our table statement. Create table user stats. We're going to pull in the first and the last timestamp of the tweets, so a min and max against the created @ field. We're going to cast it into a string so it's readable and give it a different name. We're going to select the most recent tweet, so latest by offset. So the offset in the Kafka topic, tell me the most recent one, gives us the most recent tweet that they made, and then a simple count across them, how many different tweets have they had. Select it from tweets, and then we're going to group it by the username. You'll notice we don't actually need to include this username in our select clause, because the group by forms the key of the resulting message. So we create that table, and the resulting schema for that table, we say describe table, it says here is the schema for that table. You've got your aggregate fields here, and then you've got your row key, and the row key is the username. And we can prove that out. We can say let's select this information from here, and it's just a table, so we can use SQL against it. So here's my cut and paste down here. We can say select the row key, alias it as Twitter handle just to make it more understandable, from user stats where they've tweeted more than once. And we'll see if this works, because I've only just set it running, so unless we've got like a bot maybe that's spamming away. Okay, we've got a few, and they do kind of look like bots. There's one called bot, which gives it away. So here, there's our username, which is the key of the message. The first time they tweeted, the last time they tweeted, 3 seconds later, and they've had a total of 2 tweets. And if you leave this running, you'll notice down here in the bottom left corner it says press Ctrl+C to interrupt, and there's my little flashing cursor. Every time a new message arrives on the inbound stream, it gets added into this aggregation, and that predicate of the if it's greater than 1 is evaluated. If it matches that, it sends it to the screen. We're doing a continuous query, or what's called a push query. And we know it's that because on the end of it, it has this thing here, init changes. But we can actually query that state directly and just do a key value lookup, almost as if we were selecting from a regular relational database. So let's take this user here and say, I would like to know about that particular user. And so we're going to select their handle and so on from here, from user stats, and we're simply going to say where the row key is this username, and we're not going to put emit changes on the end. We're just going to run a bog standard regular SQL query. And it says, well, there's the answer, and you'll see down here, query terminated. So this particular user, this is the key, and then here's the value, the different fields associated with that particular key. And if that user tweets again and the state gets changed, and we can query it again, they probably haven't done, you can see the tweet count remains the same, so there haven't been any subsequent ones. But this lets us look up the state from this store within ksqlDB. And here we're doing it from within the ksqlDB command line interface. But if I take that Twitter handle, I can head over to Postman here and show how you can use the REST API to do the same thing. So our REST API is on the /query endpoint of our ksqlDB server. We're going to run the same query. Select the first time they tweeted, the last time they tweeted, where the row key equals this. And now we're using the REST API of ksqlDB. So here's the query that we ran, and here are the different fields. The first time they tweeted, the last time they tweeted, the most recent tweet, and the tweet count. So we're going to use this ability to run a REST API call against ksqlDB to do a key value lookup to actually create our Twitter Telegram bot. So our Telegram bot is going to take user input, which will be the user ID of the Twitter user that we're interested in. The Telegram bot's going to receive that. It's going to make a call out to ksqlDB to find out the values, and it's going to return those to the user. So to create this Telegram bot, we're going to follow a little cheat sheet that I wrote earlier. I blogged about it on here. So let's go to armoff.net, which is my blog, and we've got this blog here. It's called A Quick and Dirty Way to Monitor Data Arriving on Kafka. This talk isn't about that as such. You can go and read it if you're interested, but that as part of that blog, I walk through how to go and create a Telegram bot. So let's follow that through now. So here's Telegram. We're going to use the bot father to go and create our bot. So we're going to say go and create a new bot, and we're going to call it the Telegram Twitter bot. And it says, okay, now let's give it a username. So we'll call it armoff Twitter bot 02 because I used a different one already. So let's try again. So armoff Twitter 02 bot. Okay, so we've created the new bot, and then here's our super secret API token, which I'm sharing with anyone on YouTube. And this, you can see, is important. You've got to keep it secure and store it safely, because this gives you access to anything that the bot's going to do. So I'm going to copy that onto my clipboard. I'm going to make a little note of it over on my text editor down here, because we'll get onto that in a moment. We've created the bot. And of course you created the bot, so you've got to give it a picture because it is the law. You don't actually have to, but it's kind of fun. And we're going to create it for TwitterBot02. Send me the new profile picture. Let's go and create that. And we give it the picture. So there's our bot with a lovely picture against it. So let's go and talk to our new bot. We've got the arm off, TwitterBot02, there it is. Okay, so here's our Telegram Twitter bot. That was the name that we gave it. And now we're going to click on Start. So now we've started it and that bot's active and available for use. Now what we need to do is we need to set up our bot code itself. And then we're going to hook together our bot so that when we send out a message like this, so we'll say hello to it, that message, that hello that I've just sent, will actually get passed across to our bot code. And we're going to do that using something called ngrok in the middle. But first off, let's have a look at the code itself. Our bots that we're going to build, I've basically taken from this good tutorial here that walks through how to use Python to set up a Telegram bot. So I've taken the code from that and I've translated it into this. So within our code, you can see here I'm crediting the tutorial that I've nicked it from. We're going to talk about ngrok in just a moment. We're going to talk about webhooks in just a moment. But first off, we're going to walk through the code. So there's some stuff here which I've just taken from the tutorial. It's to do with getting the bot code to work. Here is where we're going to put our access token. So this is the access token that I copied from when the bot father gave it to me when I created it. Just watch out for this thing here. So when you create it and when you access the API for the Telegram bots, you always have /bot and then you put your token in. And you kind of think that it would be / just the full token, but it always has the bot prefix. I'm not quite sure why, it's kind of frustrating, but just watch out for that when you're working with the Telegram API. So here's our bot URL, and what happens is it's got a little thing here, so it says when we receive a message, we're going to log that to the terminal for a bit of debug output. We're going to do a lookup for the user stats passing in that message. That message gets passed across to here to look up user stats, and then here we say, well, here's our ksqlDB. Here we've got our SQL statements that we're going to run against ksqlDB. We're going to pull out these different fields, this different value for this particular key. We're going to post it to the ksqlDB, and then we're going to say if we get a good result back, let's map these different values into the fields. So we've got the tweet count, which is the first one. We've got the first tweet, and we've got the last tweet timestamp. We've got the last tweet text itself, so then 0 and 1 and 2 and 3. So this Python code I'm not proud of, I'm not a Python coder, but it does kind of work. So Twitter stats for this particular user, so we pass in the first value there. The tweet count is this, we're going to say the most recent tweet, let's say first tweet was at then, and last tweet was at then, and then a line break and a tab and say latest tweet colon and another line break, and then we put that in there. So that we need to pass in, so user maps to this first value here, tweet count is mapped to that, so then we've got the first tweet timestamp, we've got the latest tweet timestamp, and then got the last tweet itself. Okay, so if we get a match, we're going to say that. We're going to say here if there's no result found, and then if we get an error, we pass back the error. So let's hit save on that, and I'm going to hit run and do that from in here. So we set that running, and okay, so down here it says we've set it running, and now we're listening on port 8080 on localhost. So this is running on my laptop. So my laptop is listening on port 8080, but obviously my laptop is behind my router, behind all sorts of stuff, and not exposed out to the actual internet. Whereas we're going to say to Telegram, when someone sends a message, so when we send a message to our bot saying hello, that we want Telegram to pass to our bot, because we want our bot to respond to it. So we need to hook these together. So Telegram itself has got an API and it supports webhooks. So you can say when you get an update, pass me a webhook. So we're going to register that, but we need to say when you get an update, pass it to this webhook on this certain endpoint. We can't just say pass it to localhost, because that would make no sense, because that would be from Telegram's localhost, which is like somewhere up in the Telegram cloud. So instead, we're going to use this cool thing called ngrok. And what ngrok does is it lets you register a publicly facing host and port, which ngrok itself maps to something locally on your machine. So you set ngrok running locally on your machine, and it does the clever linking together. So what I'm going to do is I'm going to fire up ngrok. So let's head over to here. We're going to authorize. So you download ngrok. It's a binary. So you download it. It's there. You have to run a command to authorize it, and then you just do ngrok, run it on this particular port. And it says, okay, now I'm running. So each time you run it, you get a different host name that gets forwarded. So you've got an HTTP, a HTTPS. So this is unique. If you connect to that, that'll then map down to, as it says here, localhost on my machine whilst ngrok is running. So we're going to take that and we're going to pass it to Telegram and say to Telegram, when the bot receives a message, forward it onto this point, and then ngrok will forward that onto my local host 8080, which in turn will pass to my bot, which is running on localhost 8080. So to do that, we're going to make a REST call out to Telegram. So to do this, we're going to make a REST call against the API. The API needs our authorization token, so that we're going to take from here. So we put that into there. Again, remember you've got that bot prefix, which must always be there. And then we set the webhook, and the URL here is going to be what we got from ngrok. So that changes each time. You can see that was me testing earlier. So we're going to set that, and we're going to send it. And it's going to say, hopefully, it's going to have registered it as a webhook. Yeah, webhook was set. So now, when we go back to Python, so we're going to shove that onto the right-hand side of the screen. Okay, so we've got our debug down here. Let's bring Telegram up over here. And then ngrok itself, let's just put in the bottom of the screen over here. Because what we should see, if I just make that a bit bigger and that a little bit smaller, what we should see is when we send a message on my Telegram bot, Telegram is going to forward it to the webhook, which is ngrok. Ngrok should show it down here and say we've just received this, and ngrok will pass it on to localhost, which is what my bot is listening to, and we should see the bot do some debug outputs here saying I've received this message. The bot locally will do a lookup against ksqlDB state store and pass it back, and it should all just work. It's as magic as that. So let's try it. So let's do a lookup first. Let's just try hello and see if it's working. Okay, there we go. So we've done a hello. We saw down here it received that post. It passed it onto the bot. The bot down here says we've received the message. Someone sent us a message saying hello, and then we said query failed, bad request. Why didn't that work? And it says, okay, there was an error. The column can't be resolved. So this is why we test these things. So let's stop the bot for now. Let's go over to here. And the query that we're running, so last tweet timestamp isn't valid. So let's over here, go back over to here. Let's remind ourselves what the columns are called. Describe user stats. And it says you've got latest tweet timestamp. So this is where we're getting confused. Latest tweet timestamp and latest tweet. So that should work. So let's save that. Let's run it again. Start with debugging. Set that going. Okay, so that's listing down here. So let's try that again. So we send a message in our Telegram bot. That sends that. Okay, now that's much better. So our bot has received hello, and we were shouting this time. We did it in capitals. It did the lookup against ksqlDB. ksqlDB said, well, for that particular key, I've not got an entry for that particular key. Well, we could confirm that. We could do a query ourselves against user stats where row key equals hello, and see if that works. And it says query terminated, no rows found. So that's what our bot has said, no result found, and that's what it's sent back to Telegram. So now let's try this, and let's do that. So now we're going to query in ksqlDB down here. We're going to say show me any messages on this particular table where the tweet count is greater than 1. Okay, so let's do that, and let's just say limit 5, just showing the first 5. Let's say here are the first 5, any moment now. Let's page up, let's do this more simply. Let's do it without the latest tweet, because that's what makes it so large. Okay, so we're going to get the Twitter handle. The first 5 ones are going to come back. So here's one here. So this person here, they've tweeted 3 times. The first one is at that time, that was at that time. So now we're going to say, I'm interested in this Twitter user. I'm going to go to my Telegram bot and say, tell me about this particular user. Okay, and it says, okay, I'll tell you about that particular user. Here's this particular user. They've done 3 tweets. The first one was at this time, the last one was at that time, and their latest tweet was this. So this has all actually come together rather nicely. We've taken a stream of tweets coming in to Kafka using Kafka Connect to stream those tweets into a Kafka topic. You've used ksqlDB to declare a schema on top of that topic. We saw how you can project columns and just query it directly, but how we then run an aggregate to build a materialized view to create a ksqlDB table, which is in effect a materialized view. It's materialized as this state store within ksqlDB, backed by RocksDB, but you don't actually need to know that as a user. And that state store we queried directly using our Telegram application. Our Telegram bot sent a message using webhooks to a bit of Python code. The Python code took that message, did a key value lookup against the state store in ksqlDB, and then sent the message back to our Telegram bot. So we can try it again. We can say, let's try a different user. Let's go and look up this one here. And we can say, tell me about this user here. And it says, well, this user here, they've done this many tweets and they've tweeted this thing here. So that's how you can build a Telegram bot using Apache Kafka and ksqlDB, taking a stream of events, transforming that stream of events into materialized state that you can query directly. So go and check out the blog that I wrote about this on the Confluent blog. You can see it goes into full detail here. In the blog that I wrote, I used a different data set. I used packet capture data coming from Wi-Fi, where you can actually go to and use a Telegram bot to look up information against different devices and what they've been doing on the network. But it's the same idea, and it goes into much more detail. Go and check out the Confluent blog. Subscribe to my YouTube channel. I post lots of videos about Kafka Connect, about ksqlDB. I've also linked out to a bunch of other really useful talks about Apache Kafka, about Confluent Platform, so go and check those out as well.